So on this question, there are primarily three approaches that we can take. And I'm going to go ahead and walk you through each of them so that you can choose what you prefer. I'll give my recommendation, of course, but at the end of the day, it's totally up to you. So we do have a system here of linear equations, and we know that we do have a pretty awesome program called Solve Systems. So let's start with that approach. We'll go to Solve Systems, which is the fourth program, and notice that the format needs to be in standard form for each equation. This bottom equation is already in standard form. However, the top one is not. Now, we could pretty easily get it into standard form by, let's say, actually you have two approaches you could take. You could decide to just move this y over by subtracting it. And if you do so, on the right side, you have x minus y equals, and then all that's left on the left side is -5. And we could just rewrite it where we have x minus y equals -5 like this. That's totally fine. The other approach is we could have simply moved the x over to the left side and then added the 5 to the right side. And in that case, it would have produced -x, +y, and then on the right side, +5. So you may be thinking, well, these look like very different equations. However, they're really the same thing. It's just, you could think of it as one is multiplied by -1. So still very much the same equation. And then we, of course, have this one down here, which I'll go ahead and rewrite just so that we have it a little bit easier to see. So that was pretty quick as far as the process goes. Of course, I talked through it, but normally it's fairly quick. We'll go ahead and input the coefficients of 1, -1 for this coefficient there, and then -5. So if I'm using this equation, and then for this bottom one, we have 1 in front of the x, 2 in front of the y, and 22 as the constant. And notice we get our ordered pair as 4, 9, making the correct answer B. In case you're curious, you could go ahead and press enter since we haven't gotten out of the program. We didn't really do anything since we got our answer. And that just pops up the most recent program. And if you want to check it out, we can go ahead and plug in these coefficients in case you're thinking, well, would you really get the same answer if you had rearranged it to the other side? And you'll see that you do. Now, we can also use Desmos, which is in the upper right corner of our own software, and in the upper right corner of Blue Book, which is the software that you'd be using for the digital SAT. We'll go ahead and click there. If you had any equations already in there, you click on this gear icon, delete all, but we don't have anything there, so it doesn't really do anything. Let's go ahead and zoom out a bit, which you can either do with your touchscreen if you have one, or you hold Control- to zoom out, Control+ to zoom back in. Control-0 just gets it back to the normal viewing window. And we'll go ahead and type in these equations. So for this first one, we have y minus 5 equals x. And then for the bottom one, x plus 2y equals 22. And we'll go ahead and look for that point of intersection. The thing that's a little bit different here, we had to do a little more typing because in the program, you just type in the coefficients, whereas here you actually type in the variables. Of course, in Desmos, we didn't have to rearrange anything, which was nice. But now I have to go ahead and find that ordered pair, which isn't too hard. And we see that we still get our ordered pair as 4, 9, making the correct answer B. Now, this third and final approach, I really wouldn't recommend on this digital SAT because time is of the essence. However, I do think it is good for you to know for your own math class how to be able to solve this by hand. So when we go to our math reference document, more specifically, we go to side 2 of page 33, you'll notice that I contrast when to use substitution versus elimination. Now, substitution is really convenient if either a variable is already isolated, like in this case, y is by itself, or if one of the coefficients is 1 or -1, so you can pretty easily isolate it. Whereas elimination is convenient when either they're both in standard form or none of the coefficients are 1 or -1 because that'll produce fractions when you try to isolate that one variable. Well, notice in our case, we do have x isolated in this top equation, so I would definitely do substitution. And since x is equal to y minus 5, we're going to go ahead into this other equation, and everywhere there's an x, I'm going to replace it with y minus 5. And then we still have the plus 2y and the equals 22 that were in the rest of the equation. I'm going to go ahead and combine like terms now that I've gotten it so that it's one equation, one unknown. And then I'm going to also add the 5 to the other side. I'll go ahead and do that on the next step just to make sure it's really clear. And notice we get 3y equals 27. And then we'll go ahead and divide by 3. and we get y is 9. Now, of the options here, the only one that has y equal to 9 is option B. So again, that's the correct answer. However, if you were doing this in a class that's not multiple choice, you would need to go ahead and take that y is 9, and to figure out the x coordinate, you would go ahead and plug it back into either of the equations. Now, in my opinion, the top one seems a bit easier, so I'm going to go ahead and plug it in there, but you'd get the same answer either way. So we have 9 minus 5 equal to x, and that means that x is equal to 4.